The chain rule is kind of like the power rule, but we take the derivative of stuff and then tack on the other. It's kind of hard to say in words without using the real formal speak. So what I'm going to do is let's just go through it and do it. I have 6x minus 10. Now I'm going to use a real simple example. But just know as we progress, the examples are going to get harder. So I'm going to use a simple example. I'm going to apply the chain rule. You're going to say, why would I use the chain rule, Mr. Adams? Well, I'm using this simple example so you can see how the chain rule works. And then we'll use harder examples. All right? So this one we could do in our head. If I wanted to find y prime, right? Y prime. By the way, I'm going to use some Leibniz notation. That's the same as dy dx. Right? In other words, I'm taking the derivative of y with respect to x. So I'm going to say dy dx. And by the power rule that we talked about yesterday, God bless you, what's the derivative of 6x? And keep in mind that this is x to the first power.
0.
Wrong.
What?
6.
1 times 6 is what?
6.
Then we say x raised to the 1 minus 1, or x raised to the 0 is
So it's just 1.
1. 1 times 6 is 6. What's the derivative of 10? 0. Any constant, when you take the derivative of a constant, it is always 0. So our derivative, or y prime, is just 6. Now that's the regular way. This is like doing the power rule. But if I wanted to use the chain rule, let's think of this. Is that the same function?
Yes.
Yeah. All right. Now I did this on purpose to give you an easy example of how to do the chain rule. Clearly, if you could take the derivative of this function, just take the derivative. We're going to use the chain rule in a little more complicated situations in about 3 or 4 examples. All right. So I'm picking an easy one so you guys can kind of double check, make sure, and kind of wrap your mind around it. All right. So we could do this with the product rule, right? So I could take this derivative using the product rule, certainly. I could do a U substitution method. And then we could jump into the chain rule. But I'm not gonna use the product rule. What I'd like to do is think of this. Well, think of it like this. What if I let u equal 3x minus 5? Well, then I could rewrite my function as y equals 2u. Right?
Oh, that's what it says.
Could I do that?
Yes.
Okay. Now, one thing that we've kind of glossed over a little bit is that when I take the derivative of something, I have to tack on the derivative of our expression. And what you don't realize is that at every point, all these problems have been rigged so that that derivative that we tack on is 1. So we've never really tacked it on. So technically, when I take the derivative of this, when I say y prime, I'm going to have to say whatever the derivative is and tack on u prime. Does that make sense? So if I'm going to have to tack on u prime, I'm going to take the derivative of u with respect to x, right? Because this is a function, u of x. Well, what's the derivative of this thing?
3.
3, right? So it's just 3, right? Okay. Now what I really want is I want y prime somewhere down here. but y prime of this is actually the derivative of y with respect to x. And already we've got some shenanigans here, right? So if I take the derivative of this, I would be saying dy du, right? Because I'm taking the derivative of y. This is a function of u, isn't it?
Yeah.
Okay, does that make sense where we're going with this?
Yeah,
Okay, because this is important. So what is the derivative of 2u?
2.
2, right? So that's just 2. So, okay. Well, I got dy du, du dx, but what do I really want? I want y prime of this bad boy, which is dy dx. So, what if I took dy du and multiplied that by du dx?
The d is
The du's cancel, and what do I get?
dy over dx.
Or you could have just started with dy over dx.
Well, you couldn't have, actually. Now this is where the product rule and the quotient rules kind of derive from. Alright? So now, this is also leading up to the chain rule. So you're right, the du's cancel, and I get dy dx. But, so what I'm really saying is y prime, or dy dx, which is what we're interested in, right? Which is really the derivative of the expression 6x minus 10, which in this particular case we have written in this way, 3x minus 5, right? We want the derivative of this, prime of this, which is dy dx. But we know that it's dy du. What's dy du?
2.
2. Times du dx. What's du dx?
3.
Right. Huh.
That's no accident.
That's no accident.